They say.
Okay, we're going to try this one.
But would it be worth it?
This morning I made the mistake of the class, and I asked them to give me numbers, and they gave me numbers, and their denominator number is like 27. Those numbers got into the hundreds of millions before we got done. I said, no, I'm not doing that yet. So I want this to be something that we can be successful at. Hey, let's focus. Focus. Now, it is true when you look at this problem that you don't have to long divide this one. But I want us to practice the long division. I want you to see how it works. And I'm hoping maybe we can go through it fairly quickly, somewhat on your own. And then I'm going to come back and talk about synthetic division. And we're going to do the same problem with synthetic division and kind of compare, and maybe in our minds, how difficult we think the two types are. But also, hopefully, you can recognize if we do them right, we will get the same answer. There's a big if in that. So please try to set this up for long division, work through the long division, and then see where we go.
This is just another example.
Another example. That was the goal. Let's try to get it done.
No, I've been.
Oh, I'm.
Is this still long division?
This is still long division. Just a few more minutes. No. If you believe you can get it done, you just sit there quiet for a few minutes. Anybody get what I got? Make sense? Question about it? Some of you might have made a little bit. But it's a fairly straightforward process if we follow the algorithm and we just follow through with those steps. I will pretty much say that for most of us, we would rather do the synthetic style.
I made it there. No, dude. I finally did one thing right.
No, I'm.
All right. Synthetic division. Now, this one structurally looks different. Also, the amount of values we write up here on the board are smaller. We are only considering the coefficients.
139.
Hey. Guys, focus. And so, when we're doing this process, place value becomes critical. And if for some reason I did not have a particular power in decreasing orders, I would need to insert a 0 into my synthetic division statement to hold that place value. So you will have to take a moment to make sure, do I have all the powers that are available here? For this one, yes. You may not have it later, but for this one we do. Also, structurally, I think a lot of times you guys have kind of, I think you guys called it a shelf last year or something like that.
Yeah.
And then you put a series of numbers out here, which are the coefficients of this thing. The question is, how do I find the number that goes there?
I don't know.
You said yes.
Well, we're going to do a little bit of guess. It has to do with this thing right here. What's we're dividing by?
Positive 4.
And so we will actually think about setting it equal to 0. We get the positive 4, and that's what goes in this blank right here. So we do remember, like I said, we remember some of this. And then we keep track of our values. I would suggest that you give it enough space so that you know things like, that's not a negative 147, that's a negative 14 and a positive 7. So give yourself enough visual space to know that.
Hold on, wait.
The other thing that I write here to help us out is I write a plus sign because we are adding. That's also part of why a lot of students like this style. We are performing the operation of addition. The other operation we perform is multiplication. And so the first value here, we bring it down. You can write the arrow. You don't have to write the arrow. Just know that you bring it down. It's a 3. And then down here we're going to have our results. The next thing that you're going to do is you're going to take the 4 that's here times this number here, in this case 3, and that gives me 12, which is my next piece of my working step. And as the plus sign is there, I will add the 5 and the 12, and that does give me 17. Now we go back and we're going to multiply the 4 times the 17, and that happens to be 68. And we're going to add again, and that is your 54. Once again, we multiply 4 times 54. It's 216. We add 223. Now, one of the things that I do structurally, you don't have to do this, is I will draw a vertical bar trying to connect those pieces. And what I'm separating now is my quotient coefficients for my remainder. And now we have to think about, well, how do I rebuild this quotient? There's a couple ways to do it. But one of the ways I think gives you the most success is you look right here at this value, right on this side of the bar, and you say, that actually is my constant. So that's my 54. It's a plus. Then the next value is your next highest power of x. So that's 17x. And then we come up to the next one, and that's 3x squared. And again, because that's positive, it's plus. And then we look at this end and say, there's my remainder. So plus 223 over. And we go back to this one of x minus 4. Questions about that? Did it match?
Yes.
Yeah, it did. So it works the same way. It gives you the same results.
So how do you know if you can synthetic or design?
Oh, that's the opposite question. What's the highest power right here?
So it's the same. Like
If it's the first power, you can synthetically divide.
okay.
The first example I gave you in class was an x squared. You cannot synthetically divide.
Wait. Also, how would you know what to put on the shelf if it was like a polynomial there? Like, no.
I'm glad you asked that question, because that's what's coming. We got a couple more questions first.
Maybe part of it I don't remember, but like H's and G's or something. There's 2 letters, but like you have to pull them out and like make
Oh, the P's and Q's stuff?
Yeah.
That's not today.
Today on my Q's and my P's. Today on my P's and
All
my
right.
Q's.
Other questions?
So it's, you said it equals to 0 and that's how you figured it out.
What was the rule for using this?
Yeah. The highest power of this one right here is the first power. So as long as that's x to the first right there, you can use synthetic division.
Oh,
X to the first underneath and
Uh-huh. See, this one here, no, this one here, it was x squared.
time out. So you can't have a polynomial.
You only get to deal with a binomial. That's it.
Can you go back for a second?
All right. Let's try another one, see what you guys can do with this. Okay. Try that one.
Come on, brother.
Hang on a second. Let me amend it. We've got one number here real quick.
Oh,
Good grief.
There we go. We'll make that 4 instead of 5.
thank you.
Just maybe.
Wait, so find the thing that's written on the bottom, you said it equals 0.
Uh-huh. So you have to think about it as 2x plus 3 equals 0. Subtract the 3.
Oh my
And
God.
x is equal to negative 3 halves.
Are you crapping me?
No, that's what we're going to do.
Oh, brother.
Oh, brother.
This is now real
I
time,
hate
brother.
that.
Yeah, anywhere you can see it.
I'm gonna say calculator. That's what I'm gonna need the old calc for this one.
And then you add those, and you just 6 times that.
It's not cookie.
9.
Something like that.
I don't know how I did that.
You anybody else get something that looks sort of like that?
Oh, you put a
put
0.
decimals?
Why did I put a 0 in there?
Just because
Oh,
it's
no.
Yeah, there's no extra square term. Please include the place value holder.
Why'd you put 2? Oh, I see. 3
Whoa.
over 2.
Whoa.
Damn,
4
man.
times negative
Did
3
that one
halves.
bad.
I just put a 0 on accident. But it didn't work out.
Is 4 times negative 3 halves negative 6?
No.
Are you sure?
No.
Yes, it is. Because half of 4 is 2. And 3 halves of 4 would be 6.
I think you just explained that really badly. But it makes sense.
I got
I understand that you.
I got 2.5.
No.
Can we put decimals on the last number?
Oh, I know what
Why?
I did. I know what I did.
Oh. Are you sure?
Bad sense to me.
I got it.
I'm not. I'm not.
How do you add a negative 14 to that?
How do you write the remainder?
If I say negative 3 halves of 4.
Ah,
Isn't that negative 14?
It'd be negative 6. It'd be negative 6. You're wrong.
I don't think like that.
Negative 6.
I'm trying to help you guys expand your thinking horizon.
Wait, how is 0 minus negative 6? No, never mind. Never mind. No, listen to me.
Okay.
Shut up, Riley. Wait, negative.
Yes.
What?
Wouldn't it be 73 halves?
I don't know. It's a good question.
Because I got...
Yep. I'll go along with that.
How'd you get positive 9? I got negative 9. I did something wrong.
That's wrong.
Every time I say I do something wrong, you say that that's wrong. Wow.
Did anybody just do that?
Oftentimes. Yeah. Or you say that makes sense.
There you go. I agree with that. That's why I have to check my work.
Do you agree with that now?
Bro, my face is
Did you get it right, right? That's why you're proud. I'm proud of you.
Well, what do you do at the bottom? Like, what's that?
Okay. Hey, time out.
No, don't time out. Time in.
We've got a lot of different questions coming up, and I would not like to answer them but once. So, if I look here,
How many gold? No, can you go back?
right here, I'm having something that's the third power is the highest power, and I'm dividing that by an x to the first. When I take a third power and divide it by a first power, we're basically subtracting those kinds of exponents, and we lead ourselves to the x squared. So we are reducing our power by 1 by the division process. Now, we're not done with this thing yet.
Oh.
We have to get rid of the fraction.
I need to work on this just a little bit so I no longer have that fraction going
I have
on.
a question.
No.
Why did you put x plus 3 halves?
Yeah, that's why I was here.
Because that's what this was dividing by.
No, I thought it was 2x. Why wouldn't it be 2x?
Hang in there.
Dog, I can't hang in there.
Just relax.
Take it easy now.
Hey, no, anyway, you only have 12 more minutes.
Honestly, this is where it starts slipping.
And I'm still second.
What changed? Wow. I don't even understand what you did.
Multiply 2.
Oh, those just...
I can't do that.
I
don't do
multiplied
this
it by
whole thing.
2.
2 over 1, but 2 over 1.
I got you.
2.
Would you count it wrong?
Okay, but...
That's a more simplified fraction, isn't
Right,
it?
but would you still count it wrong?
Yeah.
If we got that far,
So, how, where did you get the x
are
from?
you...
3 over 2.
Yay!
Let me go back a step and then ask you a question. Right here.
The following.
Yes.
I have this as a 4. I wrote x minus 4 down there. What was in this blank was x with the opposite sign and that value. It turned out that it was identically this number.
Whoa, 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 whoa.
Right? So down here, I have what's in this blank of negative 3 over 2. So I'm writing it as x with the opposite sign of that same thing in that blank.
So that's
Right down
the
there.
0, and that's it with x. That's what you're doing.
Yeah.
Okay.
No, wait, can I see that?
Other questions?